outdoor terrains. So if you want to navigate a robot in an unstructured outdoor terrain, how do you do that? That's what I asked myself when I started this project. So let's assume you're able to map this environment with point cloud. So you can use various 3D SLAM methods to build maps of such environments, and then you can use this point cloud map to measure traversability of local paths. After you have these traversability measures, you can then use this map to create a planning pipeline. Use this traversability to sample states, and then use OMPL planners to create plans on top of these states. And then this basically becomes constrained planning problem. So we use OMPL planners to tackle the motion planning on unstructured terrain. And we perform a collision check with a 3D box that represents robot body, and then an octomap that represents environment. So each state is validated by this collision check module. This is an example plan, and robot has already followed this plan through here. So this plan goes through an inclined hill, and then it gets into the final goal. This is another example of planning. So this is all in Gazebo simulation. However, we also create a Gazebo world from data that was captured from real world. And then we use this Gazebo world to test and evaluate VoxNav. So this is another example navigation task where we give a navigation goal which is 60 meters away from the robot, and the robot here finds a path and then follows this path all the way to the goal. So there is about 2 meters of elevation variance on this navigation task. And the robot progresses here, and finally it reaches its goal with VoxNav. This is all components that composes VoxNav. So this video is too short to explain all of this, but this is good for reference. You can find the source code and documentation of VoxNav in the following links, and if you'd like to reach me, please do so. Thank you very much.